Here we have a SAT math problem. Okay, let's go with the question. X square positive k positive 1 times x positive 16 equals to x positive h the whole square. In the equation above, k and h are positive constants. If the equation is true for all real numbers of x, what is the value of k? Okay, in this equation, we have to find the value of the positive constant k. Okay, let me take the given equation as it is. That is x square positive k positive 1 times x positive 16 equals to x positive h the whole square. Okay, now let me write the stuff on the left side as it is. That is x square positive k positive 1 times x positive 16 equals to. Okay, now we have to get the expansion of the square of the binomial we have over here. So we can multiply x positive h by itself to get the expansion of this x positive h the whole square. Otherwise, we can use the algebraic identity, that is a positive b the whole square, that is equal to a square positive 2ab positive b square. Actually, it is one of the important identities in algebra. It gives the expansion of the square of a binomial, that is a positive the whole square. Okay, when I compare this x positive h the whole square and a positive the whole square, at the place of a we have x, at the place of b we have h. So in this expansion, what we have to do is we have to write x at the place of a and h at the place of b to get the expansion of the square of the binomial over here. Okay, now let me do it. Then I'm getting x square positive. For 2ab we have to write 2 times x times h positive h square. Now we can write x square positive k positive 1 times x positive 16 equals to x square positive. This 2 times x times h can be written as 2 times h times x positive h square. Okay, here we have a quadratic expression on the left side and quadratic expression on the right side. Whenever two expressions are equal, then the coefficients of like terms must be equal. Here the coefficient of x square is 1, on the right side also the coefficient of x square is 1. What is the coefficient of x on the left side? That is k positive 1. What is the coefficient of x on the right side? That is 2h. So this k positive 1 and this 2h must be equal. Because these two expressions are equal, then the coefficients of x must be equal. Okay, now let's consider the constant term on the left side, that is 16. It must be equal to the constant term on the right side, that is h square. Okay, now our aim is to get the value of k. Here we have k positive 1 equals to 2h. Okay, let me subtract a 1 from both sides. When I do so, positive and negative 1 will cancel out. I'm getting k equals to 2h negative 1. Okay, if I know the value of h, I can plug in over here and get the value of the constant k. For that, we have to solve for h in this equation. Here we have 16 equals h square. So to solve for h, we have to get rid of this square over here. For that, we have to take square root on both sides. Whenever I take square root on both sides of an equation, for one of the square roots, I have to consider positive or negative sign. Usually, we consider positive or negative sign for the square root which contains number inside. This square root contains number inside, that is 16. We can consider positive or negative sign over here. Then I'm getting positive or negative. The value of square root of 16 is 4. And here the square root and square root cancel out. I'm getting h on the right side. We get two values for h. One is h is equal to 4 and other one is h equals to negative 4. Okay, so the question clearly says k and h are positive constants. So we can reject this one because here h is equal to negative 4. Let's consider only the case where we get a positive value for h. Okay, now to get the value of k, we have to plug in this 4 for h over here. Then I'm getting k equals to 2 times 4 negative 1. Then k equals to 2 times 4 is 8, 8 negative 1. Then I'm getting k equals to 7. I got the value of the constant k equals to 7.